Alright, so here we are with the 8-3 notes on solving right triangles. So, we're going to use trig ratios and their inverses to find angle measures and to solve right triangles. So, first we're going to talk a little bit about some inverses and opposites. So hopefully we know that the opposite of addition is subtraction. And then after multiplication, the opposite is division. Then you may remember when you learned about square and then square root, right? Those are opposites. And so the idea is if I take x squared and square root it, I go back to the original formula. So that's what's happening here. If I take inverse of sine, and you do that by using the key that has a -1 there, or if I take the cosine inverse, or the sine, or tangent, inverse. If I take that of the previous sign, or of the previous operation, I'm going to end up with just x again. So again, opposites end up undoing what you already did, and so therefore bringing you back to what you started with. Again, this key is if you use the second key on your calculator and then pressed sine, you would end up getting sine inverse. Alright, so the next one is your inverse trig ideas, and so as we look at this, notice I'm doing sine inverse of sine, and so what it's going to equal is x, because those two cancel. Same thing happens for here, those will cancel, leave you with x, and the same thing here, these cancel and leave you with x. Alright, and so again, it's that idea of x squared square rooted leaves you just with x, because the square and the square root cancel. Alright, so what does that mean for solving? We're going to find the acute angle measure based on being given two sides. So, taking a look at our first one here, in order to find angle A, so that's over here, I need to identify that angle A has an opposite of 5.4 and a hypotenuse of 12.2, and of course adjacent, as much as it's there, is not going to be working in here. So when I think of SOHCAHTOA, the only ones that don't have adjacent in them, tangent does, cosine does, sine does not have adjacent in it. So we're going to solve this by saying sine of my A angle measure is equal to opposite over hypotenuse, or sine of A, again we don't know what A is, but it equals 5.4 over 12.2. Now to solve this so that I can get A equals, how do I undo a sine of both sides? Well, I would take the sine inverse of this left side, which would cancel the sines, and leave me with A. But because I did it to one side, I have to do it to the other. So I'm officially going to be solving sine inverse of this fraction. So in your calculator, you press second sine, so you have sine inverse, then 5.4 divided by 12.2, and we're left with 26.27. And that is a degree, so degrees. Hopefully as you're doing this, you are in degree mode, because we're trying to get degrees back out, so we want it in that mode. So the same process is going to happen for this next one, only we may or may not be doing sine, so we'll see. So if we're talking about angle E is going to be subject to this being the adjacent side, this being the opposite side, and this being the hypotenuse side. And just as we did before, we're not using hypotenuse because it doesn't have a measurement on it, so I'm not going to use cosine and I'm not going to use sine because they both have hypotenuse. I'm going to use tangent. So that means that tangent of angle E is going to equal opposite over adjacent, or technically tangent of E is going to equal the opposite length, which is 7, over the adjacent length, which is 6. And so to solve, I need to undo the tangent to get the e by itself. So tangent inverse of this left side and tangent inverse taken of this right side means that I'll have an angle E that equals the tangent inverse of 7/6. So second tangent inverse, making sure you're in degree mode, gives you 49.40 degrees. Alright, and then our last one here, we're trying to find angle J. Angle J has this 56 as its hypotenuse, this 23 as its adjacent, and this GH over here as its opposite, which again means that I'm not caring about anything with an opposite, so not that one, not that one, and so I'm going to do cosine. So that means I'm setting this up as cosine of my angle, and that's going to equal the adjacent over the hypotenuse, which means that cosine of J is actually going to equal 23 over 56. And so to solve, I'm going to take the cosine inverse of both sides. Remember, that cancels the cosine and leaves you with a J. And then the cosine inverse of the fraction. So second cosine gives me cosine inverse. And then I'm going to write dividing 23 and 56. Close the parenthesis. And we get 65.75 degrees. Alright, so again, that is how we solve these. We go through and set up the proportion, or well, the fraction at least, and then we're gonna do an inverse in order to get the angle measure. So, taking a look at this one, they want you to find the unknown measures and round the lengths to the nearest hundredth and angle measures to the nearest degree. So anytime that they say solve a right triangle, that means find all of the missing pieces. So in this case, I want the length of ST, I want the angle measure of T, and I want the angle measure of R. So ST, angle of R, and angle of T. So how do I get that? Well, it's a right triangle, so I know that I can use some trig, but let's start with T. T is in association with this being the opposite side, and this being the hypotenuse side. Again, thinking of SOHCAHTOA. If I have an opposite and a hypotenuse, that means that I'm talking about sine. So sine is going to be of T, and it's going to equal my opposite over my hypotenuse. But that means that sine of the angle T is actually equal to 5 over 5.7. And so to solve, I can take the sine inverse of the left side, leaving me with T. And I can take the sine inverse of the right side to even that out. And so second sine is going to be 5 over 5.7. So 61.31 degrees. Alright, then to find the rest of them is actually all of the things that we've known before. So for instance, to find angle R, you just need to take the fact that a triangle has 180 degrees, subtract out the 90 that they gave you, and then subtract out the 61.31 that they gave you. And so now we know that angle R is actually 28.69 degrees. So now I have angle T, which is 61.31. I have angle R, which is 28.69. And then I can do more trig if I wanted to, but I doubt I do. Instead, I'll just use the Pythagorean theorem, because this is a right triangle, so I know that a squared plus b squared is going to equal c squared. Meaning, if this is my a value as a leg, and this is my b value as a leg, then this is my c value as the hypotenuse. And so I can plug in 5, don't know what b is, oops, I like how I wrote plus equals c squared, and c is 5.7. If we solve, that means 25 plus b squared is going to equal 5.7 squared, so 32.49. And then from there, we'll subtract out our 25, leaving us with b squared equal to 7.49. But of course, to solve, just as we've seen before, square root of a square leaves you with that side length, but then we have to square root the other side. And so we get 2.74 for ST. All right. So there's kind of our answer bubble, if you will, but we only really needed to use trig once. We found our angle, and then from there we used our own ideas of the triangle sum theorem, adding to 180, and the Pythagorean theorem, since it's a right triangle. All right, so this next one here, we're going to identify triangles from trig ratios. So we're going to use the trigonomic ratio, trigonometric ratio, that cosine of A is 24/5, to determine which angle of the triangle is A. So in order to do this, we're going to go ahead and, again, we're trying to find out if this is A or if this is A. So if we first pretend that angle 1 is A, we're saying that cosine of angle 1 is going to have to be based on SOHCAHTOA, because we're doing cosine. We need our adjacent over hypotenuse. So that would have been 1.4/5. And we're trying to see if that equals what they gave us, which is 24/25. Definitely not equal those decimals. So if we try the other one, which of course by process of elimination we know works, cosine of angle 2 is going to be represented by this being the adjacent side, and this still representing the hypotenuse. And so we have 4.8/5. And we're seeing if that equals 24/25. And so if you divide 4.8 and 5, or if you divide 24 and 25, both of them are 0.96. And so that means that angle 2 is A. Alright, taking a look at our last problem, we're going to solve the right triangle in the coordinate plane. The coordinates of the vertices of the triangle are P of -3, 3, so this is P. Q is 2, 3, so this is Q. And R is -3, -4. And we need to find the side lengths to the nearest hundredth, and the angle measures to the nearest degree. So, PQ is not going to be so hard because you can just count it. 1, 2, 3, 4, 5. Perfect. We can also count our PR. And so PR is 1, 2, 3, 4, 5, 6, 7. And so we do actually need to find RQ using another method. And in this case, we can use the Pythagorean theorem. So if we know that that side is 5 and this side is 7, in order to get our C side length, we can use the Pythagorean theorem of 5 squared plus 7 squared equals C squared. 5 squared would have been 25, 7 squared is 49, and so putting those together, we get 74. But of course, taking the square root of both sides leaves us with a C of the square root of 74, which is 8.60. We'll put that up here. Then we know because of a horizontal and a vertical line meeting at 90 degrees, that angle P is 90 degrees. But in order to find angle Q, for instance, we need to use some trig. So if I take a look at angle Q, the opposite side that I counted was 7. The adjacent side that I counted was 5. And so to find angle Q, I would need to use opposite and adjacent. Looking at SOHCAHTOA, Opposite and adjacent is tangent. So to find my Q angle, I'm going to set up that tangent is the opposite, 7, over the adjacent, 5. And then we solve to get the angle measure by taking the tangent inverse, which will cancel the tangent. And once we find the tangent inverse of 7/5, we'll have the degree measure. Tangent inverse of 7/5 leaves us with a Q of 54.46. And then to find our last angle, angle R, we can take 180 minus 90 minus 54.46, which we just got. And that leaves us with an angle R of 54.46, 35.54. Whoops. There. So we've got angle R, angle Q, angle P, and our side lengths. Again, just as we did in the previous example, we used, or not the previous example, we used trig first, then Pythagorean theorem to find that one missing angle, and then subtraction from 180, which again we did here, Pythagorean theorem in order to find the missing side length, and then trig in order to find that missing angle, and then the fact that they add to 180 to make the whole triangle. So kind of a lot of steps, but make sure that you follow each of those and then we should be fine.